Welcome to Understanding Money Management, EGN3613, Engineering Economics. This is Module 5, Lecture 1, and I'm your professor, Dr. Ron England. I'm going to take you through some of the nuances of money management that we haven't covered yet. You may think that we've gone through almost everything dealing with time value of money, but reality is we haven't. We have the ability to calculate the equivalent value of money through a number of different types of payments: single payments, series payments, gradient payments. We've got future worth, present worth, and values of constant series of payments. We've got values of, we've got the variables of the amount of money, time, and interest rate, and we can do comparisons to get the equivalent amount. So you think you've got everything necessary to calculate the value? Well, guess what? You'd be wrong, because money management is a little bit more complex. So there's a few things that we also need to learn how to do, but the biggest thing that we have to talk about is interest rates, because guess what? Interest rates aren't as simple as you might think that they are. There's the concept of the nominal and an effective interest rate, and equivalence calculations actually change when you actually talk about effective interest rates. And we also got a little bit to talk about in the concept of debt management, because if you owe money, it's not like you owe it as a linear thing. It's a little bit more complex than that. So first, let's talk about the concept of nominal versus effective interest rate. Okay, a nominal interest rate, which you've seen all the time, is an interest rate that you get quoted on an annual basis. And that's probably going to be the case almost all the time. The interest rates that you see are going to be calculated annually. They're going to be given annually. But the reality is the effective interest rate will probably be more. And why? Well, the reason why is compounding. So let's take a look at an example. That might make it easy. Suppose we talk about an interest rate of 18% compounded monthly. Okay, well, that is a nominal interest rate, but it also is given annually. It's 18% annually, but it's compounded monthly. What does that actually mean when we do that? Well, if we take that 18% interest rate and we break it down into a monthly interest rate, simple, 18 divided by 12 is 1.5, so we've got 1.5% interest per month. All right, but it's also getting compounded on that monthly basis. So the interest that you're paying on that first 1.5% actually compounds into the next month. So the number of interest periods is now 12. So the reality is you've got a series of payments, 12 payments on a period of 1 month of 1.5% each. Well, guess what? You can actually calculate the present and the future value of that series. And when you do so, guess what you find out? Future value is actually 19.56, is an effective interest rate of 19.56. You're actually paying more than 1.18. It's 1.1956. Yep, that is the case. So the reality is 18% compounded monthly is the same as 19.56 real interest rate compounded annually. Guess what? Yes, that makes the entire concept of money management a little bit more complex. But the reality is, if you get that real interest rate, the effective interest rate, what it really means is that you can use that effective interest rate when you're trying to do present or future worth, or even worth of a series. So bottom line is that 18% compounded monthly is really 1.5% per month for 12 months, which is actually 19.56 when you truly 19.56 when compounded annually. Now, when does this actually occur? Pretty much whenever you've got monthly payments. Okay, that's just how it works. 1.5 interest each month on the unpaid balance. Guess what? You earn, and well, of course, in your earnings, if it's deposit, means you're actually going to get more. So how do we do this? How do we do the calculation? Well, the reality is what we need to do is we need to convert it to an effective annual interest rate when we've got a compounding period that's different from the annual period that you've got quoted there. Well, the calculation isn't really that terribly hard. You've got variables of the effective annual interest rate that you're calculating. You've got the nominal interest rate per year and the number of interest periods per year. So it's just 1 plus r over m to the m minus 1. And you can easily do this calculation and get the effective annual interest rate, and then you use that later on to do the calculations of present or future worth or worth of the series on the annual basis. All right, so let's do some problems here. I'm gonna skip through these and just kind of give you an idea of what's going on. But I want you to see the numbers, because what I do expect you to do if you're in my class is you're going to work through these calculations just by pausing the video and looking at the numbers and doing the calcs. So let's say your credit card calculates the interest based on 12.5% APR. What is your monthly interest rate and annual effective interest rate, respectively? And what happens if you skip some payments? Okay, what does that actually do? So in the case of the monthly interest rate, you can now do a calculation to get the annual effective interest rate. And from that, it's not too hard to figure out total outstanding balances. What you're doing is you're just calculating, hey, what is it when you apply that? It's the good old F over P, straightforward to do. Okay, not hard. That I of A is not hard to do either. Okay, now quarterly. What's the big difference here? Okay, compound quarterly. Well, if you're saving it, it's compounding you quarterly. That's actually probably a good thing, because it means that it's compounding it and giving you that interest on a basis other than that 9% interest that you got. So how do you calculate that? Well, you get the interest rate per quarter. Okay, you convert that to an annual effective interest rate, and now you can calculate that balance at the end of year one. But that's after 4 quarters. So after 4 quarters, you've done 4 quarters at that specific interest rate, or 9.31 of the annual effective interest rate. They're both going to be the same. You can do this calculation. They should both be the same. And it's more than what you would have had if you had not compounded quarterly. That's great for you when you're making it. It's bad for you when you're paying it. All right. Put it on a quarter by quarter basis. You can actually see what you're doing is you're taking, okay, base amount plus interest, add that interest in the second quarter. Now you've got actually a new base amount. You add that in that next quarter. You add that one into the next quarter, and you get more value after the end of 1 year. Okay, again, not hard calculations. This is the equation. Remember that equation I told you to memorize? Okay, that F, this is it. Only we're doing it on a quarterly basis versus an annual basis. Okay, so that. Now, you've got a number of tables that you can use to do these things and look them up. This is called the these effective rate tables. And notice that I actually have a few of them here: compounded semi-annually, quarterly, monthly, and daily. And yet there's actually another one in there that is not listed. But this is actually very useful. You can easily calculate this. This is not a hard calculation. But if you notice, effective rates go up as the compounding period goes down. That's actually exactly what you would expect to happen. Okay. Now, do you need an effective interest rate? Well, if you're going to be doing a comparison of future and present values, or doing that type of analysis, you sure do. Okay. Now, at this point, if you've still got questions, I expect you to go ahead and pause a little bit and write them down, because we're going to be moving on. Okay. If this makes perfect sense to you, get the concept right now. An equation is an equation. The concept is what is important.